Jai Hind all of you. Myself, Dr. Nitya Sharma, Assistant Professor, Ajay Kumar Garg Engineering College. I welcome you in the next lecture, Corrosion and its Mechanism. This is part of Engineering Chemistry Syllabus, Module 3. This time the code is KS102. On the second semester, it is KS202. Now, we are going to discuss it. So, what are the main questions which can be asked in case of corrosion? That is, what is dry corrosion? Explain corrosion phenomena involving oxide film growth. What is pilling Bedworth rule? It is related with the dry corrosion. Both the questions are similar kind of type and can be contained as the one type of answer. How stability of corrosion product affect rate of corrosion? This is part of pilling Bedworth rule itself. And the second part is what is explain electrochemical theory of corrosion, or we can say what is the wet corrosion and its type. So, we will discuss these two parts, what the corrosion exactly it is and what could the dangerous type of consequences of this corrosion. We can see, if you do not forget the 1984 tragedy, Bhopal gas tragedy, which occurs due to just corrosion, the gas leakage, methyl isocyanide was leakage. All this tragic incident happens due to a very small reason, that is corrosion. So, this could lead to so much deformation and so much tragic incident, and that is why we have to study the corrosion in details so we can reduce and reduce the consequences of this corrosion. So, what is corrosion exactly is? So, first we learn what corrosion is. It is destruction of metal of an alloy. It could be a pure metal or it could be alloy because of chemical or electrochemical reaction with its surrounding environment or medium. So, what happens when we are talking about the metal? It is metal itself, it is an part which is very reactive. Why this is reactive? Because it is thermodynamically not stable. Why? So, in short, we can say this is deterioration of metal or destruction of metal, that is result into consequent loss of solid metallic material through what is the relationship by which it does takes place? It does takes place with chemical or electrochemical attack. And who is attacking on the metal? That is environment. So, environment is attacking. What are the weapons of environment for the attacking? That is either electrochemical or some chemicals which are already present in the environment. So, on whom they are attacking? They are attacking on a metal. And what is the result? That is destruction of metal. It is so simple. So, thus corrosion is reverse process of extraction of metal. In nature, we obtain metal as an ore which is thermodynamically stable. Either it is metal oxide or sulfide or nitrate or whatever in the form, the metal itself, it's converted into its oxide or sulfide or nitrate or whatever, which we called as ore. Through the metallurgic process, different metallurgic process, we obtain the pure metal which is thermodynamically stable. Metal itself, any metal generally having their tendency to convert them into positive ion. Now, this positive ion is when the negative ion, any negative ion meets to this positive ion, it forms a stable compound. So, metal itself, it is thermodynamically stable, and what the metal will do to get it stabilized? It will corrode itself and convert into corrosion product. So, which is again thermodynamically stable. So, if we say the environment is attacking on the metal or metal itself inviting the gases to convert it into its ore, as metal will convert into that metal, here it is metal and it is converted into Mn positive ions. So this Mn positive ions, whatever the ions are available for this, either it is oxide or it is hydroxide, generally these two are available in the environment. So they form with the metal and convert into corrosion product, which is in general are referred as corrosion product. So there are two types of corrosions we are going to study, two types of mechanism of corrosion rather. It is, the first one is dry or chemical corrosion, in which the moisture is not available or lesser available, and the second type is galvanic or electrochemical corrosion. It is also referred as wet corrosion. So these are the important part of the types of corrosion. Now dry or chemical corrosion or oxidation corrosion, what is this? We are going to see this. So whenever surface of metal is due to direct reaction of atmospheric gases, it could be any gas like oxygen, halogen, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, H2S gas, and if any fumes of chemicals with the metals are there, then we are in the surrounding of these chemicals, then what will happen? This particular metal, whatever the chemical affinity of metal towards the reactive gas, so according to that metal, it convert into its respective ion or respective compound. So generally, in general, oxygen is present in the atmosphere. So it is mainly responsible, and that is why it is also referred as oxidative corrosion. So because in general, in environment, in normal case, only oxygen is available in abundance and oxygen itself is very reactive. So generally oxygen do get the responsibility of corrosion, that's it. So three types of dry corrosion is the first, the foremost and most important in the dry corrosion is oxidation corrosion, which is reaction with the oxygen. Metals which get directly reacted with the oxygen in absence of moisture, moisture is not there, and that is why it is referred as dry corrosion. So in general, we are taking example of alkali and alkaline earth metal, though many metals are there also which are responsible, which shows this kind of corrosion. We will see how. So they react with the oxygen at room temperature and form corresponding oxide. So what basically corrosion is, what we are talking about till now, metal, destruction of metal is corrosion. So corrosion is metal is converting into its ion. This is corrosion. This is corrosion product. This is not corrosion. When we say what corrosion is, then rusting is corrosion. Rust is product of metal, of which is referred as generally in normal conversation, it is iron. But the corrosion is conversion of metal to its positive ion is referred as corrosion. So this is corrosion and this is corrosion product. So please do not ever confuse between the two terms, what is corrosion and what is corrosion product. So corrosion product is metal oxide or metal sulfide or metal carbonate or whatever the formation which is resulting out as product of corrosion. So corrosion is conversion of metal to its ion, and corrosion product is whatever is forming afterwards, that is corrosion product. So metal is converting into Mn positive ion by losing N electrons, and these electrons when meeting with the oxygen, as we are talking here about the oxidation corrosion, it is converting oxygen into oxide ion, and then it will combine with the metal and form M2O, where here it is taken M2O. Why it is taken? Because it is referred as alkali or alkaline earth metal here, and this is just an example. It can be if this N will vary, then obviously this molecule will be vary itself. So now the Pilling Bedworth rule. What is Pilling Bedworth rule? It is on the surface of corrosion. That is, smaller the specific volume ratio, greater is the oxidation corrosion. So let's make it very simple. Seems to be complicated, but it is very simple. Volume of metal oxide. So generally when we are talking about the metal surface itself, suppose this is a piece of metal. Over here there is layer of oxide. So then what is the nature of this layer of oxide? What is the volume of this metal oxide? That volume is to volume of metal which is exposed. One thing has to be taken care, that corrosion is always a surface phenomena. It doesn't occur in the near this part of the metal, it always occur on the surface. So whatever surface is exposed to the metal, that part will only corroded, other part will remain safe. So whatever is exposed part of metal, that is volume of metal exposed, that part will be corroded. And if the metal oxide cover itself, this metal oxide is basically what it is doing, it is covering the metal itself, then sometimes it covers, sometimes it don't. So we will see how in the next part. So when it is covering and the volume of metal oxide is more, then volume of the parent metal, the corrosion will be less. And if volume of oxide layer is less and volume of parent metal is more, then corrosion will be more. So this is, more is the volume of metal oxide, lesser will be the corrosion, right? How it is? We will see the types of, when we see the types of oxide film, then we will see. So generally during the oxidation, metal is formed as thin film on the metallic surface, which protect, what basically this is doing? This is protecting the metal. How it is protecting? Because it is covering the metal, and so this metal is no more exposed to the environment, and environment is only the weapon which can attack the metal. So what are types of metal oxide? How many types of metal oxide can be formed? The first one, stable tightly adhere oxide film. We have generally seen copper deposited, which is covered by the green copper oxide. Aluminium form a black layer on its surface, which is referred as aluminium oxide, and tin also does the same. So this oxide of lead, aluminium and tin are stable, hence inhibit further corrosion. So what happened? Suppose we are having this as a metal surface, and this is completely covered by oxide film. So no more surface is covered, and when no more surface is covered, then it will protect the further corrosion, as again the corrosion is the surface phenomena. Now the next example is porous oxide film. Very common example, which is of iron. Whenever iron is there, in case of this, suppose iron is there, pores we can see in the rust. So this is somehow exposed, these pores expose the air, and so environment can attack on the metal surface. So in this case, the corrosion rate is moderate. In this case, corrosion rate is quite slow. Once the film is formed, further corrosion gets stopped. As just for example, if we call the copper, then once this green color oxide layer completely cover the copper, then further corrosion gets stopped. Similarly, in the case of aluminium, in fact, in case of silver also, that black layer which is formed, which further prevent the corrosion. So the reaction rate is quite slow. The second one is porous oxide film. In this case, The moderate rate of corrosion, yeah. Now the volatile oxide film layer. Whenever the sodium, just for example, sodium, when you see the sodium, what is famous for the sodium? We will keep in the air and it will burn. Why this is so? When we are keeping the sodium, it will get attacked by the environment. The corrosion product is formed. Corrosion reaction. It is generally oxidation reduction reaction takes place. That is so volatile and exothermic, it burns quickly. And so, whenever volatile oxide film is formed in case of molybdenum and corrosion, this is very fast. And the last type of corrosion, whenever unstable oxide layer is formed, means what? M is converting into Mn positive, but this Mn positive is not stable. It is again converting into metal, and so we will see that there is no corrosion here. In case of gold, platinum and silver, sometimes silver also, which are referred as noble metals, it is seen that no further corrosion is there, and that is why they referred as no corrosion. So, some second type of oxidation corrosion, when the other gases are involved like chloride, sulfate, H2S and nitrates. Dry corrosion, when react with the metal and from the corrosion product, some examples are dry chloride react with the silver and from AgCl, which is again a protective layer, and so further corrosion will stop. Now the tin chloride is volatile, so it will result out into the faster corrosion. H2S if formed, then it result out into corrosion product. Moderate corrosion will be there, and liquid metal corrosion is also there. So this is third type of oxidation corrosion, where the liquid metal corrosion occurs. Liquid metal corrosion, when it is in case of molten metal is there. In case of then it pass through the pipes and it result into internal penetration. One example is mercury, and somewhere when hot molten metal are used, that is the example. The next part of the corrosion is wet or electrochemical theory of corrosion. So, when we are talking about electrochemical theory of corrosion, and we have to revise what electrochemical cell is. First, we will revise what electrochemical cell is. In case of electrochemical cell, there is one part which is referred as anode, and another part which is referred as cathode. Always oxidation do takes place at anode and reduction do takes place at cathode. This is anodic reaction and this is cathodic reaction. So, what we say, what is anodic reaction? Zinc, this is just a galvanic cell which we have studied previously. Zinc is converted into zinc 2 positive by losing 2 electrons, and at cathode these 2 electrons are absorbed by this copper chloride solution here, that is Cu2 positive here, and which is converting into Cu. So, what if we see in physical meaning, what is actually happening? In this case of, in this anode, this is dissolution of metal is there. This is dissolution of metal. So, after some time when we will see this metal, this metal will be dissolved into this zinc 2 positive. Means zinc will convert into zinc 2 positive, concentration of Zn2 positive will increase. Now, in case of copper chloride at the cathode, what is happening here? This is deposition of metal is taken place. So, when we are talking about this part, so my question is where the corrosion is taken place. I am repeating my question. In when I am talking about anode and cathode, I am talking about zinc and copper. Can you answer please where the actual corrosion is taken place? Again, I repeat it. What is corrosion? Corrosion is deterioration of metal. What is deterioration of metal? Conversion of metal to its ion is referred as corrosion. So, what is now corrosion is? Corrosion is this, right? You are very right. Anode, at anode, corrosion is being taken place. Anode, zinc is converting into its ion by losing electrons. So, corrosion is being taken place at, yes, right, anode. So, this is the main part of base of the electrochemical theory of corrosion. When it occurs, when it is conducting liquid or two dissimilar metals which are attached to each other, which are immersed partly or dipped into solution, then this type of corrosion mechanism do occurs. So, these are the main points of the corrosion. So, main points of the corrosion, which is also referred as galvanic cell corrosion, because it occurs on the surface of metal. The first and foremost always has to be remembered, it is always occur on the surface of metal. Now, some parts of metal surface will act as anode and the rest will act as cathode, sorry. So, what occurs? What is going to happen? It occurs as anode and the rest will act as cathode. It will occur on the same metal, only no two metals may or may not be attached to each other. If I am talking about this one metal, then one part may act as anode, another part act as cathode. Or vice versa. It can be happen depending on the conditions. We will see. The chemical in the environment and humidity will act as an electrolyte. Okay. What will, when we are talking about an electrochemical cell, there are three important parts. One is anode, another is cathode, and the third one is electrolyte. Electrolyte which provide the medium of for the electrons and which is responsible for the electron displacement or exchange. So, electrolyte, what is going to work as electrolyte? The environment and the humidity is going to work as an electrolyte. The third point, oxidation of anodic part takes place and it result corrosion at anode, and obviously reduction will take place at cathode, and the corrosion product will formed on the surface between the anode and cathode. So, revising the 4 points again, which are the most important point of the introduction of corrosion mechanism, wet theory of corrosion or electrochemical theory of corrosion. The first one, corrosion will always occur on surface of metal. The second point, some part of the metal will act as on the surface, of course, act as anode, the another part will act as cathode. Then environment will act as electrolyte, corrosion occurs at anode, reduction occurs at cathode, corrosion product is formed on the surface of the metal between anode and cathode. Now, we will see how it occurs actually. So the two types of corrosions are there, two types of electrochemical corrosions are there. One, evolution of hydrogen type when acidic environment is there. Whenever acidic environment, when we can say when the pollution is there in nearby the red lights, where the more consumption of fuel is there, and so the different gases are also there, which is forming the acidic environment, and it will result into the acidic type of electrochemical corrosion. And the second one is absorption of corrosion, wherever the environment, wherever the electrolyte, what is the role of environment? This is electrolyte. So on the basis of this, their product will be changed. Their product will be changed. What? Corrosion product will be changed. So these are the two types of corrosion. One is with the acidic environment, the second with the basic or neutral environment. Now my question is, which kind of corrosion you see more often? Generally, when we are talking about the acidic environment and when we are talking about the basic or neutral environment, in normal condition, when it is we are in what we are living, normally is basic or neutral environment. So more common type of corrosion is this. First, we see evolution of hydrogen type of corrosion. The basic points will be the same. At anode, oxidation occurs. What is oxidation? What is corrosion? At anode, corrosion occurs. Iron will convert into iron 2 positive by losing 2 electrons. So, in case of evolution of hydrogen type, there is small cathodic area and this part is large anodic area. Okay. So, there is small cathodic area and large anodic area is there. Corrosion will always occur at anode. So, what part of metal is going to corrode it? That is anodic area. What reaction will going to happen here? Iron will convert into iron 2 positive by losing 2 electrons. Now, these electrons are going to move towards the cathode. Why they are going to move towards cathode? Because here this hydrogen is going to be captured H2 positive. We are having environment acidic. Acidic environment is abundance of H positive in the environment. This H positive will get these electrons which are coming from the iron to iron 2 positive, and so hydrogen will be evolved. This is gas. This reaction is going to take place at cathode. What is going to take place at cathode? And again, what is corrosion? Corrosion is conversion of metal to its ion. So, our overall reaction we can say Fe plus 2H positive is converting into Fe2 positive plus H2. Now here, depending on the environment, depending on the presence of gases, this iron will form some product. Here one thing has to be noted again, this anodic area is larger and cathodic area, cathodic area is smaller, and so this corrosion mechanism, whenever the pollution is there, this corrosion happens very fast. This is faster than the absorption of oxygen type of corrosion, or we can say corrosion is faster when environment is acidic, or we can say the corrosion is faster when there is much pollution. How they are related with each other? Pollution, if pollution is there, then it will increase into the presence of H positive ions. H positive ions will attack on the large anodic area. Large anode means more corrosion. Large anode, more corrosion. Small anode, less corrosion. So, when in case of absorption of oxygen type of corrosion, so what will happen? This type of corrosion takes place in neutral or basic medium. Obviously, this is more common type of corrosion is there. The oxide of iron covers the surface of iron and the small scratch. What happens? We are talking about the layers. There are very general methods which we use to prevent corrosion. Just for example, galvanization is done. What is galvanization? Protecting of iron from the zinc oxide layer is galvanization. So, suppose this is our metal layer, complete metal layer, and we got some scratch, some pit over here. Then this part of metal is exposed to the atmosphere. And when this part of metal is exposed to the atmosphere, then what will happen? This part will act as small anode and this part will act as large cathode. The rest part will act as large cathode. So, this part, what the reaction is going to take place? Corrosion is very simple. Iron is converting into Fe2 positive is corrosion by losing 2 electrons. But these 2 electrons are moving towards the cathode. Again, this Fe2 positive, which are they are positive, electrons where the electron are going, so the iron is going as well. Electrons are much lighter, much faster. They will reach to the cathodic part fastly and they will meet oxygen with the moisture is there because this is wet corrosion. That is why it is referred as wet corrosion. So, 2 electrons meet to 2 oxygen and they are going to form hydroxide ion. Now, these hydroxide ion will further form FeOH whole twice, that is ferric hydroxide. Now, this again depending on the points are again there. So, in this case what has to be points? There are small anode. Generally, the common type of corrosion it is. When the corrosion occurs from a pit, then it is referred as pitting corrosion. There are different kinds of classification of corrosion. The basic theory will remain the same. So, further if oxygen is abundance, what will happen? Ferric hydroxide is actually hydrated ferric oxide, which is in combination of water and which is yellowish rust we see, and this mixture is also formed, mixture of FeO and Fe2O3. It is the reaction is going to occur in nature. So, we cannot say that Fe2 positive will only form. It may there that Fe3 positive can also form. So, depending on the availability of oxygen, depending on the chances of removal of electrons. So, there is combination of corrosion product is occur with Fe2 positive means ferric oxide, ferric hydroxide, and it is anhydrous magnetite also, which is brown black rust. So, when we see the rust, it is combination of different colors. Some part is brown, some part is yellow, some part is black. Why this is so? Because this is in combination of all three. Now, we see the dry corrosion or wet or electrochemical theory of corrosion. Then we can see in absence of moisture is here in case of dry corrosion. This is conducting medium is there, electrolytic corrosion is there. It involves directly attack on chemicals on the metallic surface. It involves formation of electrochemical cell. This process is quite slow because no outer atmosphere is directly attacking on the metal. This is quite rapid because water is there, which is making that moisture is making the conditions very drastic. Corrosion products are at the site of corrosion because there is no movement of corrosion product, iron 2 positive. In case of this, corrosion occurs at anode and deposition nearby the cathode, in between the anode and cathode also. And this process is uniform because there is corrosion product where the corrosion occurred. The corrosion product is obtaining at the same place, and the different types of anodic parts of corrosion product. So, depending on the corrosion, from where the corrosion is start, then it may be galvanic corrosion, pitting corrosion. When it is start from the pit, then it is pitting corrosion. What is galvanic corrosion? When suppose iron pipe is connected with copper tap, then the two metals are there, and because one part which is having more oxidizing tendency like iron, that will be corrode faster, and so this kind of corrosion is referred as galvanic corrosion. Stress corrosion, when some stress occurs on the metal surface and corrosion start, then it is stress corrosion. Service corrosion, when a service obtained on the metal surface, then it is service corrosion. Erosion corrosion, in case of soil is there and erosion occurs, then it is erosion and soil corrosion. Waterline corrosion and differential aeration corrosion are nearby the same, where the presence of oxygen concentration is different. So, where the oxygen concentration is different, then more oxygenated part will work as cathode and less oxygenated part will work as anode, and the rest is the same, that corrosion always occurs at anode. So, the part which is less oxygenated, in case of waterline corrosion, then this part is less oxygenated, it will be corroded. And if a pole which is buried into the soil in the material, this part is corroded, and iron nail which is get corroded from its lower side, this is all same type of corrosion. The basic principle remain the same, only your explanation will be changed. So, I invite you for the comment and ask more question about the corrosion. If please feel free to get me contact. Thank you everyone.